The essence of EIGRP is the dual algorithm, standing for diffusing update algorithm. Diffusing update algorithm. It is unique to EIGRP, and it's got a lot of intriguing and very detailed operation that we need to be masters of, because it is going to come up in our configuration and troubleshooting. Starting with something called reported distance. Now, this is also known as advertised distance, but we like to call it reported distance now just because we don't want to have something with an AD, because AD is normally administrative distance, something totally different. Okay, so let me show you reported distance here. Let's say we're R3. We're R3 trying to get to the 10.1.0 network. There are two different pathways, are there not? We can get there via the top pathway, or we can bounce around maybe a little bit further and go through the bottom pathway. Well, R3 is going to get routing updates via both R1 and R2. R1 and R2 are both going to advertise reachability to that network to R3. And it would have reported distances which are representative of R3's neighbor's distance to get there. So the reported distance for R1's advertisement would be 500 plus 500, which would equal 1,000. That would be the reported distance. That would be the reported distance. R2's reported distance would be 500 plus 500 plus another 500, which would equal 1,500. Now, the reported distance is used in the dual algorithm for what is considered the feasible successor test. The feasibility condition, we'll talk about that later. But the reported distance, also known as the advertised distance, is a big factor. It's a big deal to us. It also comes into play when we're looking at unequal load balancing. So EIGRP has this unique behavior of considering the reported distance. Next, we'll look at the metric. Now, if we were to go to our topology, we would see metrics all over the place. That's the metric right there. We would call that the feasible distance. I'm going to go over to R3 actually. And let's look at the EIGRP topology table. I'm going to do a show IP EIGRP topology. And what we can see is this right here. That's called the feasible distance. The first value in the parenthetical, that's called the feasible distance. The second value, that's the reported distance, which should never be as big as the feasible distance. We also have this thing called a successor. The successor is the best route to get there. And if we're doing equal load balancing, we'll have two successors. So let's apply what we saw in that topology table. We saw the reported distance in that second part of the parenthetical. We saw the metric, which is called the feasible distance. And then we saw these things called the successor routes, which are the best routes to get to that destination. Lastly, there's something called the feasibility condition, which we'll look at later. But what this has is an equation that compares reported distances and feasible distances to ensure we do not have a loop in our backup pathways. The backup pathways are called feasible successors. So we basically just say we have to test to make sure that we have feasible successors. We may not have one. You might have a topology with a backup pathway that doesn't pass this test. But if it does pass the test, we are assuredly not installing an alternative route which is considered a loop. It is loop-free because that's what dual is really testing for.